This video is about conditional probabilities, or probabilities that have this word given in it, from a two-way table. Okay, so when you see a problem where it says the probability of some A condition given some B condition, then you know you're looking at conditional probability. Okay, and another way to write this that I will use, a shorthand, is where you have the probability of A and then a vertical line and then B, and that's that's read as A given B. Okay, so what this is equal to is I'm looking only out of B happening. So looking only at the cases where B happens, so down here, the probability that B happens, okay, what's the chance that A also happened? Well, if B already happened and A is also happening, this happens to be the probability of A and B both happening. Okay, and that's kind of our formula for conditional probabilities. Okay, this has been filled out in the previous video. If you want to look at how to fill out a two-way table, look at that video. Okay, but I'm going to be answering these questions down here. Based on the table, actually I need to see the table too. A randomly selected person completed the survey is male. Okay, although it doesn't say the word given. Okay, this is basically the probability that something happened given that they're male. Okay, so I'm assuming that someone who filled out the survey is male. What is the probability that he rates the library service as good? So, given that they're male, what's the chance, that they rate the survey as good? That's the question. Okay, so I'm looking again at out of males, the probability that they're male from the survey, and the probability that they rate it as good and that they're male. Okay, I'm looking only at the cases where they're male. Now, in the table, I'm looking only at this row. Okay, given that they're male, I'm only looking at this row right here. Okay, so out of the males, and there's 241 males. Okay, out of the males, what's the chance that they rated them as good? There's 91 males who rated it as good. Okay, if I divide 91 divided by 241, I get the decimal 0.378. Okay, next, a randomly selected person who completed the survey is female. So they're saying the probability of something happening given that, female. Okay, what is the probability that she rates the library service as good? So, given that the person is a female, what's the chance they rate it as good? Okay, and again, I'm looking at out of only the females. What's the chance that they rate it as good? So this is good and female. Okay, well now I'm looking only at this row right here. This out of the females. Okay, well how many total females are they who responded to the survey? Well, there's 274 females who responded to the survey. Okay, and how many responded as good? Well, 93 of them responded as good. If I divide 93 divided by 274, then I get the number 0.339. Okay, let's go the other direction, which may seem very similar, but it's not. Okay, a randomly selected person who completed the survey rated the library as good. So now it's probability that given that it's good. Okay, what is the probability that this person is male? So if I know they rate it as good, what's the chance that they are male? Well, and now I'm looking at this right here. Looking right here out of this good, assuming that they rate it as good, well, how many rated it as good? And of those, the chance that they are male, and because they're in that column, and good. Okay, now those that answered good is 184. Okay, the chance that they good and are male is 91. Now this number is the same as before, but what it's out of is different because my condition, what it's given, is different. Okay, 91 divided by 184 is the decimal 0.495. Okay, and finally, a randomly selected person who completed the survey rated the library services as good. So again, I'm looking out of the ones who rated it good. What is the probability that this person is female? So now it's female given good. So looking out of those that responded good, again in this green column, the probability that it is female and good. Okay, those that responded good is 184, the same as before, but now female in that column is 93. If I divide 93 divided by 184, I get the decimal 0.505. Okay, so this video was about conditional probabilities. Probabilities where you have something given something else. There's some condition, okay, and it's always this formula. And this is a video about how to do it with a two-way table.